So again, my name is Dr. Jim Lani, and I'm here to kind of show you a streamlined way of conducting analyses. We have to go over some basics first, because you got to learn to walk before you run and crawl before you walk. So we're going to go over some basics and then really show you the tool that really helps to streamline not only the identifying of the analyses and the data cleaning of the analyses, both important, the conducting of the analyses with the assumptions associated with those analyses. And then, as a bonus, we offer up a discussion chapter draft. So you can kind of go from raw data to chapters 4 and 5, or if you're a DMP, whatever chapters you want to call that. And so just to, kind of highlight some of that. One arc. All right. So let's get started here. So we'll understand some basic levels of measurement, what an IV and a DV are. These are kind of basic stuff, but you need to know about it. We'll talk about data cleanup. As it turns out, data cleaning is 95% of the job. Sometimes I put it at 90, sometimes, but never lower than 90. It's the most arduous, could be boring. If you don't do it right, repetitive. Okay, so data cleaning is an important task. And I'll just preload you with the, running descriptives on that data that you've inputted is really important. So you can see, the range is correct. The sample size is correct, basic things, okay? We'll talk about test selection. We'll talk about chapter 4. I should have put it up top, but I have a discussion draft, and then we'll get to the demo itself. So basic things. Data has 3 different types of characteristics. It's nominal, name only in Latin. So it's just red block, blue block, green block, Republican, Democrat, Independent, just names, no hierarchy. Okay. Ordinal has names, 8-ounce Coca-Cola, 12-ounce Coca-Cola, 64-ounce Coca-Cola. It has names, but it also has an order to it, and it's identified with that bar graph. Scale has all 3. It has a name, 1 inch, 2 inch, 3 inch. It has an order, 1 before 2, 2 before 3. But the key thing is that the volume or distance or interval, okay, is equal. That allows you to do things like divide and do other kinds of mathematical operations that you couldn't do on, or adding, nominal level variables, it's not going to happen. Okay. IVs and DVs, as it turns out, they're teaching us younger and younger now. My 9-year-old came home to like, hey, here's what a DV is. I'm like, you're kidding me. That's what I'm teaching. And I'm trying to explain it to her as well. And the dependent variable is just the outcome variable. It depends upon the participant or the observation, okay? So, if I want to look at 5K run times by gender, the dependent variable is the run time, and that depends upon the participant's time that they ran. The independent variable is controlled by the researcher. I want to look at it by gender. I want to look at it by region. I want to look at it by age. That's in the researcher's control, okay? So broadly speaking, dependent variables depend. Independent are really researcher controlled. The most common problem I get is what kind of test, even from faculty, okay? Deciding what tests, and by the way, this is okay. We do this every day for 3 decades. You're doing this in a class 6 months ago or a year ago and now, or faculty also, not on a daily basis. So selecting the test is important, both for your scholarly project or your dissertation or for publication. But we have a mode to do that, okay? But if you're stuck there, join the club, okay? That happens. Show you how to conduct it, show you what the output means. Our output is in plain English prose. So what that means is that it will interpret it for you, okay? You should vet that. The results is not AI driven. So it's all driven by R with lots and lots of code behind it. So while we have, aligned the number output with the interpretation, it's your job to understand that, own that, and okay. So, all right. We'll talk about loading up your data. You can load up in CSV or Excel. You can load up SPSS. You can paste a flat Excel file in there. But importantly, how you manage that data is important. I see in working with faculty and students, data is messy. Okay, it's just the nature of the beast. But at some point in time, all that data needs to sit in one file. I get 5 files. They need to all be combined, and specifically speaking, that each participant needs to be on a row, whether they're in a control group or an experimental group, whether it's their outcome variable, whether it's pre-test and post-test, all in the same row. Okay. Always, always. You never have other orientations. Okay. The data cleaning wizard, I'll just briefly touch on it, but given my comment that it's a vast majority of the project, it seems like a trivial thing, but it's kind of not. You have to validate that level of measurement. If you upload a number to Intellectus or other things, they think it's a number. It's going to upload it as nominal, pardon me, as scale, when in fact, one represents this age group. The second, number 2, represents this age group. So, which is ordinal in nature. So you have to make sure that those levels of measurement are accurate. Why? Because some of the tests require different levels of measurement. You cannot do a t-test with ordinal level dependent variable, okay? Composite scores are just what often happens. I have a confidence scale and I have to average these numbers or these items or sum these things, okay? Missing data is a nuanced topic. There's entire chapters written about missing data. And the general rule of thumb is, I think the general rule of thumb is, I should have that nailed down, but I can double check now. The general rule of thumb is missing data is either randomly missing, I have a 10-item scale, and somebody missed item number 4, I'm happy to impute that. If it's systematically missing, I missed all of the items, I missed 80% of the items, I think it's over 20% of the items, okay, I want to kind of delete that person, but don't quote me on that exactly, but I think that number is 20%. If you're missing that many, I don't want to impute that. Even if you have a post-test score, a survey can, that you participated in, but the pre-test doesn't have anything, I'm not going to do that. I'm going to dump that person. So it's nuance and just heads up about that. Again, for a few items here or there, it's okay to impute the mean. We have a procedure that imputes the mean plus or minus a standard deviation. It's not trivial. Some people I speak with get kind of freaked out. They're like, hey, what, a third of my people are missing data, but I still have 250 people that are complete. I'm like, where is the problem exactly? It's particularly acute when you have very few participants, okay? So that should be handled, okay? Reverse coding item is just a matter of flipping a question. You want all high numbers to mean the same thing. If you're measuring happiness, and then the third question you're measuring sadness, okay, or whatever the opposite of happiness is, unhappy, I guess. You need to reverse that items numbering. So all numbers mean the same thing. Okay. Be it happy, be it confident, be it whatever. So the way that that question is phrased, and typically if you're using validated instruments, which I absolutely recommend for many reasons, you're going to have a scoring sheet there. Okay. All right. Transform variables. Um, I don't think we should mess with that. When I see transform, I'm thinking from the number it is, like confidence, to some logarithmic scale or some square root or some darn thing. Typically, the transforming of variables in general are really if an assumption is violated and you have to kind of try to make that a normal distribution. But we'll just hold off on it. The tests, these are small sample of tests, but nevertheless, they're very common tests. So when you're doing paired, pre-paired, pre-post paired, say that 10 times quickly, and the outcome variable is scale at 2 time points only. We're doing a paired t-test that covers lots of ground, particularly for DNPs. Pre-post that you truly have an ordinal variable there. Not Likert, 5 or 7 points, but truly ordinal. 2 time points, you're doing the Wilcoxon. The Wilcoxon is also important if the assumption of normality is violated up here in a paired, you want to pivot and at least evaluate that Wilcoxon. These are also group comparisons. Okay, I'm comparing pre to post. Okay, well, it's really a time comparison. Group comparison, 2 different groups that are scale. I'm looking. So what I mean by 2 groups here is you're not in both groups. Okay, you have 2 separate groups. You're either male or female. You're either Republican or Democrat. You're either high or low on some score. Okay. T-test is your test. 3 or more groups, we're doing ANOVAs. Associations or relationships, nominal and nominal, chi-square. You can take a picture of this with your phone. Association, scale, and scale. We're going to the Pearson correlation. And prediction, the key thing is the outcome variable, also called the dependent variable, also called the criterion level variable. Sorry for the vocabulary, but they call it different things. And when that outcome variable is scale, we're doing a linear regression. If you have more than one predictor, you're doing a multiple linear regression. And if your outcome variable is binary in nature, we're doing a logistic regression. Again, you can have 1 or more predictors in these things of any level of measurement. Okay. What do you get? We format your tables for you. I don't think an adult should be sitting, struggling, making tables. You get plain English interpretation. This was significant. This was violated, whatever. And then there's other visualizations to be had. Chapter 5, this is a relatively new edition. New the past 6 months, maybe, or year. It's going to summarize your results. It's going to connect your findings to that existing literature. How does it do that? Well, one way it does that is that you have validated instruments, so it can align your particular findings with those validated instruments findings in the literature and weave them together. Okay. Talks about limitations. It talks about implications and so forth. Okay. So we'll upload, we'll clean, we'll analyze, we'll look at results, and we'll do discussion. Now's the time to log on. Okay, so if you want to do that, that'd be great. And that link is also in the Ashley, I see in the webinar chat it has login workshop, but not login quant workshop. Do I have it incorrect here or no?
Yes, that's correct. The one that I put in the chat is correct.
Okay. So let this be a lesson, everybody. Always talk to smarter people, okay? They know what they're doing. So use the one that's in the chat, okay? All right. Uh,
This is also the one that was emailed out in the confirmation email that went out yesterday and this morning.
okay. Workshop. Okay, do I have it correct now?
Um,
Login workshop, I think.
yes.
Okay. All right. Okay, so and then we'll get to Q&A. I want your problems, okay? Don't sit with your problems by yourself, okay? A tipping point is getting some expertise to help you get over that hump, all right? So we'll get there. While you're logging on, I'll put out a few contact information. Samantha can help students. That QR code will get you a 20-minute free consult where I can do a needs assessment with you. Ashley, for faculty, what does that mean? We have courseware, we have trials, we have demos, we have literature review, we have qualitative. Okay. So we have lots of things there that Ashley can support you with. Melissa, a little under the weather, but she can answer any other questions. Phone. This is our main website that's now holding all of these things together, courses, tools, and so forth. And again, my contact. Okay, so let's just navigate around this thing a little bit. So this is kind of the a priori stuff. A decision tree helps you figure out what analysis. This is not the totality of analyses, but it covers quite a bit of ground. So if I want to predict an outcome, that's scale, I'm doing a linear regression. So you can play around with this, and it's not going to get you to time series or structural equation modeling, but it is going to bring you to normal things like t-tests and regressions and correlations and chi-squares and so forth. So you need to know, okay, what an IV and a DV is, and you need to know what levels of measurement are. Once you know a U in a regression, this is a sample data plans, so you can select and say some people don't use research questions. It's okay, or study aim, but you can have a data plan that you can download and edit here. Okay, so you have data plans there, and then of course another stumbling block, which is once you have selected the test, once you have articulated the assumptions, the next question is what's the sample size? Sample size in our context is always based on the 99% of the time, based on the statistical test. And here, for different numbers of predictors in that regression, you can see sample sizes for a particular effect size. So this is kind of a priori business, all right? The meat of it is, that is the conducting of it, is in the projects where I can upload data from different file formats. I can play with an example data set, or I could paste in a flat file or just enter data. The management helps you then manage data. And most of the things folks are going to be doing is using the variable calculator to create composite scores, for example. I'm not sure if we created composite scores here or not, but probably. Okay. Years experience, for example, or time. This was a suit between when you graduated and when you had an allegation against you. So that variable calculator can do that. Importantly, also is the download data. So after you have managed that data, okay, you're going to want to keep a copy of that CSV file. Back in the old days, we used to sleep with it under my pillow because I said if my computer crashed, I'm going to commit Harry Carey. Um, so you want that data. By the way, the I think journal articles are requiring now. If they're not requiring, it will be here soon. They're going to want your data. They're going to want the tool. Okay. So they're going to want to replicate that. Another good reason for having your data. Okay. You can plot data in different ways, very simply. Again, I'm not quite sure this is the best data set for that. Let me get something simple. This is just a simple data set of age and movie and fruits that you like, hours sleep, GPAs, but you can plot that data. So in numerous ways, you can identify the variables, identify the grouping variable. Heads up about the icons over here. Okay, that's the level of measurement that is allowed in that field. Heads up, there's a video tutorial on every bottom left of both of all the management plots and analyses. So heads up there. And you can kind of see a plot of pre and post tests by different age groups. And you can mess with colors and labels and so forth. The analyses themselves are sitting here under analyses. It's pretty thorough. Um, it does descriptives, it does all the correlations. Um, t-tests are there, ANOVAs are there, regressions are there, chi-squares and other non-parametrics are there, structural equation modeling is there, and other things that people use, time series, mediation, moderation, very common. So first thing out would be to run descriptives. So let's just say I'm looking at GPA and age group. Let's just add sleep. This is mock data, so um, there's options around these things. There's a lot of default set in there, but just heads up that there's an options tab. Once you conduct your any analysis, you'll get the APA table I spoke about. You'll get a little write-up about what's in there. And for the scale variables, you'll have means and standard deviations and other kinds of things. The key thing to look at here is to make sure, oh, I have 30 participants. Good. Everyone's got an age. I have 30 participants. They're all here. I have a range. Okay. So if my GPA is 44, I made a data entry error. Very common. It happens. So, but just look at the ranges to make sure that the mins and maxes is accurate. Okay. And you want to correct that prior to doing any other analyses. Simple case is a paired t-test. I'm going to look at my pre-GPA and see if it's different from my post-GPA. Okay, so in many of these tests, we're just entering in the variables and hitting calculate. Add to the analysis. And you'll see that for each test that has an assumption, it will say assumptions, it will identify the assumption, it will identify the test used to test the assumption, it will run that test, and then interpret that test. Okay, that's a cool thing. That's been out for 13 years. So when you're struggling to figure out is a significant Shapiro-Wilk good or not, and it's not good. Okay, the results were significant. Helps. This is one way to report it. Okay, not the only way. APA table, you can see an effect size here and a little description of what that result is identifying. Okay, I think I want to take a breath, see if there's questions, um, and see where you are in the process. We've got the group has got twice as large, but ask away. Don't be shy. Where are you in your process? Let me see if anybody has sent projects over. I'll refresh. Nope. Questions you have around selecting a test or levels of measurement or the test itself or a place where you're struggling. Where are you in this process? Faculty or students? Come on, come on. We have a shy group, Ashley.
I know.
That's okay. Um, that's okay. We'll give it another minute while we're waiting for
Okay, let's
perhaps.
see. Oh, Jim, we do have a raised hand. Let's see. It's from
Sure.
we have two raised hands. Okay, so let's see. First, we will go to oh, we have three. All right, so we will start with I think Issa was the first hand raised that I saw. Issa, I'm going to take you off of mute. All right, Issa, you can come off of mute and well, here we go. I've asked you to unmute. And you can ask your question.
Hello. When I use the one-way, while Isa or Isa is looking to correct my pronunciation. When I use a one-way ANOVA, the Levine test sometimes shows significant result. Okay. But when I want to apply the Welch's ANOVA, I don't see the option in the menu. Yeah, I think the Welch's is only thrown into the parity test. So that's a question. So under ANOVA, and then we'll figure that out. Let's just do a one-way ANOVA. So I do not see the a Welch option. So Levine test. So let's just talk about what we're talking about. Um, let's just say we're looking at GPA by age group. So the Levine test, well, a couple of things. So one, the Levine test is used to assess the homogeneity of variance. In common language, what that means is that um, those standard deviations should be similar to each other for pre and post. And it looks like the pre is twice as big as the post. All right. So that's what it's doing. Um, so a couple of things to do here. So I don't know how to get you the Welch here. So let me put that out there. What can be done is one, if you have a large sample size, say north of 30, then I don't think that the impact of normality is going to have um, invalidate your results. One. The other thing is if the normality is violated, you may want to consider a Kruskal-Wallis test, which also looks at differences on GPA by DV, by age group, using mean ranks. So that would be an alternative, okay, to that. So those are two options for you. Kristen, my question is, how do I label the questions in my pre-test, post-test if uh, if they're identified only with a checkbox? No numbers or letters assigned to each question. Just number them. The test has a total of 10 questions. One is true, false, and the others have 5 choices. Okay. So there's a couple of ways of handling that. One way would be, so just to get everybody on board here. I have, pre-1, pre-2, pre-3, pre-3, dot, 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 and you have post-1, post-2, post-3. Okay, so basically what's happening here is you have a true, false, and then these are on the 1 to 5 scale. Okay, and these are on the 1 to 5 scale. And the question is, what do I do about that? So there's 2 things you can do. One is, well, first of all, um, first of all, we can turn these into, well, we can turn these into correct or incorrect. Okay, so if that question, if the true was correct, okay, then perhaps I could. So let me just scale this. If true was correct, maybe I could put a 1 there. If false was incorrect, I could put a 0 there and put that into the same variable. So one, you want to turn their responses into whether it was whether true and false was correct or incorrect. That's one thing. The second thing you can do is one is you can look at pre-1 at a pre-test compared to post-1. Okay, you can just do some chi-square because truly that's nominal. Really, that's correct or incorrect. So that's one thing you could do is just look at that. The other thing you could do is say, okay, gosh, this is all measuring confidence or whatever. I don't want to equally weight these. One thing to do would be to change these onto a 1 to 5 scale. Okay, so turn these into 5s, keep the 0, turn the 0s into 1. Now everything is on a 1 to 5 scale, and I could average or sum as appropriate. So I think that would be the thing to do there. Some require multiple answers, some require only one answer. Well, that's a common thing too. So, particularly with check all that apply, okay? Check all that apply, you can't have, you can't, excuse me, you can't have check all you apply in one variable. You need to divide that out. So, all right, and here you have A, here you have A and B, here you have C, and so forth. All right. So let's just say that you have something like this. Check all that apply. What you need to do is to create 3 other variables. Okay. Multiple A, multiple B, and multiple C. Okay. And here you're going to have a 1, okay, for any time you have an A, and 0 for these. For multiple B, I got a 1 here and a 1 here and a 1 here. These guys are 0. And for the C, okay, all I have is, okay. All right. So you need to turn any multiple choice, particularly all that apply kind of stuff, into different variables. That's the correct way to handle that. Okay. All right. In data transformation, scale variables sometimes have 7 to 8 digits after the decimal point. Is there an option to limit them to 2 decimal places? No, there's not. You're welcome. Um, I'd probably handle that in Excel. I'd probably download it, get rid of the decimal places, and copy and paste in those numbers. I think that's the quickest way to handle that. Other questions, thoughts? Okay, so while we're waiting, I will just say that we also have a quantitative tool that can assist you with thematizing, not just really kind of the few questions tagged to your quant survey, but a true interview. It can come up with codes and themes. Okay, briefly. Also, we have a lit review tool, um, which is able to upload your PDFs and then give you a nice little schema of what the theme of these articles are, who they're from. Then it gives you a synthesis of each cluster of articles and a gap in literature. So you have a clustering process. You guys are probably all past this, but for your colleagues, there's a clustering process, a synthesis of those clusters, a gap in literature, and soon we'll be adding a theoretical framework up top, which will tell the whole story. Okay. So just to know that those two tools are out there as well. Okay. My question is related to the discussion part. Oh, thank you. Okay, so I didn't get there. Thank you for the question. And then I'm sorry, I should have just duplicated this thing because as you can see, I've worked with several projects. I need to put that up top. I don't know if it's going to help me or not, but I duplicate. Okay, it should be sitting up top. So, so here I had a simple data set. I conducted simple analyses, descriptives, correlations, and so forth. But I also ran a discussion draft. When you conduct the discussion draft, you just click discussion draft, click here, and then it's going to want some information from you. Okay. It's doing a little back in the scenes to look at the variables from your results. You'll have to name the draft, add your research problem, purpose, research questions, and then identify these things. EE was meant to be emotional exhaustion, but sometimes it comes up to employee engagement. Okay, so you need to identify each of the variables here. Okay, once you do that and then generate the draft, you can view a draft, and that draft will have an introduction, an interpretation that is kind of consolidating your findings, theoretical and practical implications of your findings, limitations, future research, and a conclusion and references. This is AI driven. AI has gotten better and better. Nevertheless, you need to vet every word, okay? And every reference, particularly the DOIs. Okay. So they're on that, but that's not perfect yet. Esther, did you want to ask an additional question about the discussion, or did that help? Okay, I think we're okay. All right. So I will make this a quick webinar. Other webinars are coming up around qual or DMPs, and Ashley will make sure everyone gets the recording of this as well as the upcoming webinars. Please share with others, people struggling with SPSS or in vivo or other things. So do share webinars coming up. And then here's some contact information for us all. Um, and I see Esther is here saying I couldn't retrieve the discussion last time. If that happens, Esther, I would just hit the refresh and just start over. Okay. Um, so that refresh button is just up here. Okay. Just to reload that page. So that just seems like a one-off. All right. Okay. Thanks everyone for joining. I wish everyone a very, very happy Easter, a safe Easter, and thanks for your attention. And I look forward to seeing you next time.